So now with the signal basics out of the way, let me come back to these different update methods. You can update signals by calling this update method. And when using this approach, you have to pass in this function, which automatically receives the old value and then must return the new signal value, which of course can be based on the old value. Alternatively, as mentioned, you could have also used the set method. Now set, unlike update, does not take a function though. Instead, set simply takes the new value. So in this case, for example, the new number that should be stored in that signal. Now, if that new value should be based on the old value, you therefore either would have to use update, or when using set, you would have to get access to the old value first, which you can get by again calling this signal as a function and then adding 1 to it, for example. This is your alternative to calling update like this. So we're getting this signal value just as we're getting it in the template by executing the signal as a function in the component, just also by adding this in front of it to get access to this property. But that would be an alternative to using update. The last alternative is that you call mutate. And mutate is really an updating method that's meant to be used for values that can be mutated, which numbers cannot. You can overwrite a number with a new one, but you can't change an existing number. And to show you the difference, let's simply switch actions to a signal. Because right now, it isn't a signal yet, but we're going to change this now. We can change this by, of course, again, executing this signal function, which we're importing from Angular core. We can pass our initial value to it, which in this case is an array. And the special thing about arrays is that arrays in JavaScript are mutatable data structures. You can push new values onto an existing array. You don't have to replace an array with a new one. Instead, you can edit the existing one. Now at the moment here, I'm getting an error because of course this signal, which I'm creating here, is not matching this type signature. I'm telling TypeScript that actions stores an array of strings, where it actually stores a signal that contains an array. So therefore here we should get rid of this type annotation. And instead, to make it clear which kind of data will be stored in this signal eventually, we can add opening and closing angle brackets here, to take advantage of the fact that this signal function is a so-called generic function, to which we can add a type annotation by using these opening and closing angle brackets. And then here we can define the type of data that will be managed by that signal, in this case an array of strings. So now with that, actions now also is a signal, and if we now want to update it, we therefore have to reach out to actions. And instead of calling push, as we're doing it here, we now again have to update it by calling set, update, or mutate. Now set and update are both about assigning a new value to this signal. Mutate, on the other hand, allows us to technically also assign a new value, but by editing an existing value. Mutate, like update, takes a function. You have to pass a function to mutate. And like update, it gives you the old value. So in this case, the old actions array as a value. Angular will call this function for you and will pass in this old value to the function. Now the special thing is that you can now simply use this old value. And if it's an array, as it's the case here, you can, for example, simply call push and push your new value to this array. So that's how you could now update this signal value. And mutate is simply a helper method that exists to make the updating process of arrays or objects, so of mutatable data structures, a bit easier. Alternatively, we could also update this signal by calling the update method and getting our old actions, and now returning a new array which has all the old data points and adds the new one in addition. This would also be possible. Now, what you should not do with update is that you call old actions push. That should only be done with mutate. But you can, of course, create a new array that has all the old array entries and adds a new entry. Well, and with that, we can, of course, then also go back to the component. And here, to now use this signal, we again have to execute it as a function. And that's something that's easy to overlook or forget, but it is crucial. If you're working with signals and you're wondering why your UI is not updating, double check that you're executing your signals as functions, as we're doing it for the counter and for the actions now. And with all that, if you save all these changes, you can go back and you can still increment and decrement, and the log is being updated, and now all these things are happening with help of Angular signals. And with that, that's almost it for signals. Now there are more features to be added, and there are so-called RFCs, request for comments documents, which you can read to learn more about signals and their development process. And if you would dive into this Angular Signals RFC, you would also see that there are actually multiple RFCs that you can read. For example, also an RFC about signal-based components. And that's now a new feature which is not part of Angular yet. So this syntax does not work yet, but which is likely to be added in the future. So this signals feature is absolutely not done. There's a bit more to be added, and of course I'll keep you updated regarding that. But the main feature, so the fact that you can manage your values as signals, and that you can then update and read them, already exists. And now to conclude this section, there are just two additional features which already exist in Angular and which I also want to mention. And the first one would be the computed function, which you also can import from Angular core. And computed then takes a function as a value, and you must pass a function here. And it's a function that does not take any input, but a function that should then return a value, typically a value that's based on other signals. For example, here we could read the counter signal and multiply it with 2. And computed exists to give you an easy way of creating, well, computed values. So values that depend on other values. Other signal values to be precise. So here double counter would now be updated by Angular whenever this counter signal changes, and only then. And double counter then of course could also be used here in your template. You would use it like a signal, so you would execute it as a function. Angular would also memorize that double counter is being used here, and it would understand that double counter uses the normal counter as an input, so as a value inside of this function, and Angular therefore recomputes double counter whenever this counter changes, and it then updates the UI whenever double counter changes. So Angular watches for all these changes, and therefore computed gives us a smart and easy way of computing values that depend on other signals. And with that here, you see that the counter now indeed is basically doubled. The last signal-related feature I also want to introduce here is another function provided by Angular, the effect function. Now, effect is a function that could be executed here in the constructor, though you're not limited to the constructor. You could also use it in other places, for example, in the ng-on-init method, but here I'm using the constructor. And effect, just like computed, takes a function as a value. So again, this must be a function here. In this function, you can now also use signals, but the idea behind effect is not to produce a new value, but instead to run code whenever a signal changes. So for example, here, I can console log the current counter value. And as always, counter must be executed as a function here because that's how you read a signal value. So effect therefore allows you to define code that depends on signals, and Angular will automatically re-execute this function that's being passed to effect, and therefore this code here in the end, whenever any signal being used inside of this function changes. So in this case here, Angular understands that this code uses this counter signal, and whenever this counter changes, and only then, Angular will go ahead and re-execute this code. Therefore, if you save this and you open your developer tools, you also see the counter being output there. That's coming from this effect function. And that's it for signals. As mentioned, there's a bit more to come. At the moment, this feature is in developer preview. It's not final and stable yet, but you definitely can play around with it. And in the future, signals might give us a nice alternative way of handling change detection. As mentioned before, you won't need to switch to them. You can totally ignore signals now and in the future. And you will also be able to add them to your existing apps without changing everything. That will also be possible. But this new feature definitely gives us a new, exciting, and possibly performance beneficial way of handling data changes, and therefore Angular 16 is another pretty interesting and exciting new Angular version.